Hi there. So today we're going to work on probability of compound events. And the lesson essential question is to compare and contrast tree diagrams and the fundamental counting principle. So the first thing I want you to do is take a look at the notes where it says Tyler wants to take a class at the community center. The table shows the class options he is considering. All of the classes are offered only on Monday and Tuesday. So let's take a look at how we use the sample space to figure out how many different combinations or outcomes there are in the choice of having a class of drawing, martial arts, or dance, and then a choice of Monday and Tuesday, okay? All right, so we have drawing, martial arts, and right in the last one, dance right here. Now, these are going to be offered on Monday and Tuesday. So you can see we have Monday, Tuesday here. So let's just shorthand this M and T for Monday and Tuesday. And then here, our sample space is we could have drawing on Monday and Tuesday. So there's two options. Martial arts we could have on Monday, but we could also have, let's just put MA for martial arts, on Tuesday. So if we follow this along here, we have dance on Monday, we put D for dance and M for Monday, and then we can also have dance on Tuesdays. So it asks, according to the table, how many classes is he, Tyler, considering? So we have 1, 2, and 3 different classes. That's drawing, martial arts, and dance. How many days? Well, there's 2 days, Monday and Tuesday. How many combinations are there? So as we look at the combinations, we're going to count off how many we have. We have 1, 2, 3, 4, 5, 6. So how many different class and day combinations are there? Well, there's 6. So when we look at this, we can say the probability, theoretically, he will choose dance on Monday. Well, there's only 1 dance on Monday. So the probability of him choosing dance on Monday is 1 out of the 6. And you can just leave that as a fraction. So this is an example of a compound event. They consist of 2 or more simple events. So when we look at the last question here, how are the numbers of classes and the number of days related to the number of outcomes? This is our outcome. So when I look at my 3 and my 2, I'm thinking, how do I get that 6? And I think I just chose the wrong one here. So 2 and 3, well, I know that 2 3s make a 6, meaning if I multiplied 2 times 3, that would give me the 6. So you can use multiplication instead of making a tree diagram to find the number of possible outcomes in a sample space. This is called the fundamental counting principle. So let's take a look at genes. It says find the number of different genes available at the gene shop. Then find the probability of randomly selecting a 32 by 34 slim fit. And then we want to answer the question, is it likely or unlikely that the genes would be chosen? So let's start with the waist sizes. We have 1, 2, 3, 4, 5 different waist sizes. Then we're going to multiply that by the number of lengths. We have 1, 2, 3 lengths. The number of styles, 1, 2, 3 styles. So we're going to multiply. 5 times 3 is 15. 15 times 3 is 45. So from here, we want to figure out how many combinations there are that give us a 32, 34 slim fit jean. And there's just this one way that we can make that jean combination. So that's 1 out of 45. So let's write that over here to the left. We have 1/45th chance of pulling that jean out randomly. So let's look at that as a decimal. Remember, that fraction bar is a division sign, so let's take 1 divided by 45. We get this decimal of 2/100ths that repeats. And lastly, let's take and convert this number into a percentage. So I like to say we're going to move that decimal to 2 to the right, or you could say we're going to shift that number 2 to the left. Either way, you get the same answer. It's going to come out as 2% rounded to the nearest whole number. If you're round to the nearest 10th, then 2.2. Let's just take it to the nearest whole percentage. So it's about 2% chance. So is it likely or unlikely? Well, 2% is really highly unlikely. It's unlikely we're going to choose this one specific pair of jeans at random. So roll the dice. 2 number cubes are rolled. What is the probability that the sum of the numbers on the cubes is 12? Well, let's start here. The sum on the numbers, the only way we can get that is a 6 plus 6 on the dice. So there's one combination. And then how likely is it that the sum would be 12? Is it likely, unlikely, or just as likely as not? So we're looking at how many different ways can we roll the dice for 1. There's 6 different numbers on the dice for both. 6 times 6 is 36. So there's one way we can roll that 12. So that's 1 out of 36. So let's take and divide by 36. Now you're going to come out with this long decimal, and that 7 is going to repeat. So when we go to round this to a percentage, it comes out to 2.7 repeating. So as we're looking at this percentage, let's just round it to the nearest whole number, which takes us to 3%. So what is the likelihood of rolling? Is it likely or unlikely? This one is definitely at 3% unlikely to occur. Toy box. A box of toy cars contains blue, orange, yellow, red, and black cars. A separate box contains a male and a female action figure. What is the probability of randomly choosing an orange car and a female action figure? Is it likely or unlikely that this combination is chosen? So why don't you pause the video and see if you can figure this one out, and then come back. All right, so let's come up here. We know that we have blue, orange, red, yellow, and black cars. So 1, 2, 3, 4, 5 different cars. So we're going to multiply that by how many action figures? We have a male and a female. So there's 2 action figures. So there's 10 different combinations of cars and action figures that we could potentially pull out of the toy box. So what's the likelihood? Well, there's just one orange car and female combination that we could get. So that's 1 out of 10. So from here, remember, we want to change that to a decimal, which is 1/10. And then we're going to convert that to our percentage, which is 10%. So is it likely or unlikely? Here, it's still unlikely to occur. How'd you do? All right, so on the back page of your notes, the last practice problem here for your notes. You're looking at choosing one math class from algebra and geometry and one foreign language class from French, Spanish, or Latin. And then we want to find the probability of choosing geometry or Spanish from those two course options. So looking at the first one, we have algebra and geometry. So the two choices, we're going to take and multiply that, if you haven't done already, by our 3 language choices to get our number of outcomes, which is 6. So there's 6 different ways that we can mix and match the classes and the language, the math and the language classes. Geometry is only, and Spanish is 1 out of 6. So remember, we can take and divide and change that into a decimal. So if you take 1 divided by 6, you're going to get 0.16, and that 6 is going to repeat. Now 1/6, we know that it's unlikely. 0.16, when we look at that, it's really easier to understand that as a percentage. So when I go to write this as a percentage, I need to remember that's 0.166, and I want to round that off. So it's going to be approximately 17%. So when we're looking at the likelihood of this to happen, it is not likely. So I hope you enjoyed the lesson. If you need to go back through, slow down the video, take some more notes, please do so, and good luck on your practice problems. So let's take a look at this first practice problem. It says to use a tree diagram if you need it. So we're finding the sample space, then finding the probability. So our sample space is that number of outcomes. So we're choosing from an ice cream cone and then the flavor of the ice cream. So we have waffle, plain, or sugar. So that means I have 3 different ice cream cones. My flavors are chocolate, vanilla, or strawberry. Which is your favorite? Which is 3 options. So remember, we want to multiply those to get our outcomes. So there's 9 different ways that we can rearrange the ice cream cone and the ice cream. So I want to know, what is the probability of getting a sugar cone with chocolate? That sounds delicious. So there's only one combination for a sugar cone and chocolate out of the 9. Now, what is that probability? Well, it's 1 out of 9. We can also, remember, express that as a decimal and a percentage. So if you take 1 divided by 9, did you get, let's go with that repeating 1. Now the percent is 11%. Remember, we just can take that decimal, shift it over. And then is it likely to happen or unlikely to happen? This is unlikely. So it's not likely that somebody's going to choose that, but you know, there is a possibility. So on the back, there's another problem. If you haven't done it yet, go ahead and work on that problem choosing classes.